Honors Algebra 2 Pre-Calculus. We're doing section 6.3 in Pre-Calc. We're talking about direction angles again. So we already did this for the unit vector, but I'm showing that for any vector v, you can find the angle theta, that is its directional angle, essentially by doing the inverse tangent of b over a, meaning the y component over the x component, or the vertical component over the horizontal component. So we're going to do this in an example. All right, so we're going to do this in an example. We're going to start with, we're going to say that vector v is, let's do 4, 4. Right, so vector v is 4, 4. So if you were to look at this picture, right, this is definitely in quadrant 1, right, because you're going 4 units horizontally and 4 units vertically. So you're definitely in quadrant 1. So the answer you get here will, when you do inverse tangent, be an acute angle theta, right? So my theta is the inverse tangent of a 4 over 4. Well, that's just the inverse tangent of 1, and a thing to point out here is that that's one you should know, right? That's on the unit circle. So that ends up being either, if you're in radians, pi over 4, or it ends up, if you're in degrees, being a 45 degrees, right? So we should know where tangent is 1 on the unit circle, and it's at essentially the pi over 4's tangent is 1 or negative 1, because the x and y coordinates are the same. So if I were asked to find the directional angle here, I would say that it is 45 degrees, which fits with what I can see, which is that I'm in quadrant 1, and 45 degrees is a quadrant 1 angle. So, and what I didn't write in the example, sorry, at the start, was find the directional angle. Right, so find the direction angle, right? Now if I do that, so we'll go ahead and call that A. If I do it again for a second one, let's say I give you some W, right? And I'm going to go ahead and say that W is, we're going to stick with this unit circle theme because I think it's good for us. So, yeah, so we'll stick with the unit circle theme for example, and I guess it's not example 1, right? This is example 10, come on brain, 10, my bad. So we're going to go ahead and go in quadrant 2, right? So quadrant 2 has negative x's and positive y's. So if I draw W as negative root 3, comma 1, what we're looking at here is negative root 3, which is slightly bigger than 1, and then up 1. So we're looking at something that looks sort of like this, right? And so we want to find this directional angle, again, measured counterclockwise from the positive x-axis, right? So we want to find that directional angle, and so the way we're going to do that is we're going to do the inverse tangent of 1 over negative root 3, right? Now, again, because this is one that's on the unit circle, you actually don't have to think of it as an inverse tangent, and we can actually walk through this really quickly, how you would do it on the unit circle. But if you type this in your calculator, what's important here is that you're not actually going to get this answer. You're going to get a slightly different answer. You're going to get an answer that's actually down here in this quadrant. We'll talk about that in a sec. So if you do this with a calculator, right, and we're going to stick with degrees for right now. So if I do this with a calculator, so I go to my mode, and I'm going to switch to degrees, which is not where I normally am, right? So if I quit out of this, if I wanted to do the inverse tangent, right, if I do the inverse tangent of this 1 divided by a negative root 3, right, which is going to look like that, right, I'm going to get a negative 30, which is fine, right? But what I want you to notice is that negative 30 doesn't make a lot of sense, right? So I get that this is a negative 30 degrees, but that's not the quadrant I'm in. I know I want this angle, not this angle. Like, this is the negative 30, and it would have the same tangent value, but that's clearly not the angle, the direction I'm going in. So essentially, I want the one on the opposite end of, like, this makes a line, essentially, and I want the one on the other side. Now, there's two ways to do that. You can either recognize that if this is a 30, then this angle must also be a 30, so this is a 180 minus a 30. Or the other way to do it is to recognize that this angle of negative 30 is a full line away from the angle I actually want, which would mean add 180. So either way, the theta that you actually want is going to end up being 180 degrees minus that 30, meaning I want 150 degrees as my angle, right? Because again, I can see that I'm definitely in quadrant 2 because a positive x and a negative x and a positive y puts me in quadrant 2. What I was trying to say, but then reversed it, was that in quadrant 4, I have a positive x and a negative y, which is not the situation I'm in. So what I was saying before, though, about the fact that you could figure out B from the unit circle, just like we could figure out A from the unit circle, is if you were asked where the tangent on the unit circle is a 1 over a negative root 3, right? That's the same as asking where you have a 1/2 on top of a root 3 over 2 with, and then I'm going to cheat here, it doesn't actually matter which floor is negative, with opposite signs, right? And there are two places that happens. That I have a y value of 1/2 and an x value of √3/2, but with opposite signs, and it happens at these two places. At 150 degrees, which we just saw is the answer we want here, and at 330 degrees, which is also the same as -30 degrees. So again, I'm picking things on the unit circle intentionally here, but I don't necessarily have to.